All right, so this is number 8 on the momentum worksheet. An astronaut of mass 80 kilograms carries an empty oxygen tank mass 10 kilograms. He throws the tank away from himself with a speed of 2 meters per second. What was the speed? No, with what speed does he start to move off into space? Interesting. Um, so it's really a collision, and it's really an explosion. Um, So before the explosion, you've got the astronaut. Here, I'll draw an astronaut. There's the tank, okay? There's boxes. So there's the astronaut, there's the tank, okay? And then after the collision, let's see what happens. So I'm just drawing a diagram to represent the situation. And I'm thinking before the collision, nothing's actually moving. But after the collision, the astronaut throws the tank away. So the astronaut would be moving to the left in this picture. And the tank would be moving to the right. So I'll call that T for tank. I'll call that A for astronaut. And this is astronaut and a tank before the astronaut throws the tank. So before the collision, and this is after the collision. Okay. So the total momentum before has to equal the total momentum after. This is before collision, and this is after the collision. All right. And since v before is 0, then the momentum before has got to be 0. Now, the momentum after, so I'm going to write 0 for the left-hand side. The momentum after consists of the momentum of the astronaut plus the momentum of the tank. So these vectors must add to 0, right? So how can I do that? In other words, the momentum of the astronaut is equal and opposite to the momentum of the tank. So it looks like the astronaut is moving to the left. So I'll use this arrow to represent momentum of the astronaut. And the tank is moving to the right. Its momentum will be to the right. Okay. Now, what variables do we know? The astronaut's 80 kilograms. Okay. And the tank has a mass of 10 kilograms. Okay. We don't know. We want to find the speed the astronaut moves off. So that's going to be the momentum of the astronaut's got to be the mass of the astronaut, which is 80 kilograms, times the velocity of the astronaut going back, which we don't know. And then the momentum of the tank is the mass of the tank, which is 10 kilograms, times the speed, the velocity that the tank goes off in. So that's 2 meters a second. Whoops. I'm just going to leave out units right now. Okay. So this means that these vectors are equal in magnitude, opposite in direction, right? So that means 80 v has to equal 20, right? And divide both sides by 80, and you get v is the zeros are gone, so that's a quarter, so 0.25 meters a second. And this is how fast astronaut flies away. Cool problem. Anyway, hope you enjoyed it and have a good day.